Yeah. Hello students, how are you? I hope you all are doing well, right? So in the today's class, we are going to discuss. Okay, so there is some glitch that just give me a moment of time so that I clear the things. Okay, so I think you can see the screen now, right? So basically, what I am doing right now is we have we are at the end last week of the exam. I can say that last 10 days. So I decided to give you some mock tests. I would like to solve some mock papers in front of you so that we will understand the level of the questions which are asking in the NEET exam. And these I have took from a very prestigious institute. I would not like to say the name of it, but I can say that this will definitely help you to boost your score and confidence for sure. Okay, so just give me a moment. I will join again. Okay, I'll be here. Just give me a moment. Okay, so now I would like to ask the questions from this. Okay, so take 2 minutes of time as it is live stream. Pause yourself when you got the video, but take 2 minutes of time while solving the paper. Okay, so each and every question will be very important for you, and I would like to see how you guys are doing. Okay, so pause yourself and answer the question number 51 and 52. Okay. I think you can see the screen now. Okay, so there was technical fault from my side only. The OneNote was not working from properly. So I will check this one in the next class. Make sure that I will not do that. Okay, so going forward, students, make sure that key I will give you 2 minutes of time to solve the question. Okay, right now I hope you guys are understanding what is the question number one. Okay, so question number one. The reagents used in the following conversion A and B are respectively. There is an acid and A and B are the reagents given. One is alkane and another one is also an alkane. So definitely whenever any acid or ester group has given, we should use the reducing agents for sure. So given following options, all are reducing agents. There is no doubt at all, no problem in answering that. Okay, but if you see choose only one option, so that is why LiAlH4 is the strongest reducing agent. Always remember it will reduce acids to alcohols. Okay. All the acids are carboxylic carbonyl compounds like aldehydes, okay, ketones. These will always reduce to alcohols. So, but the given LiLH4 will not going to give you. Soda lime is help in decarboxylation. What is soda lime? Soda lime is basically NaOH, okay, in the presence of calcium oxide. Okay, this is soda lime, right? So this will help in the decarboxylation. True. So decarboxylation can take place, but whereas LiLH4 will not going to give you the, yes, will not going to give you the alkane, it will give you the alcohol. True. Yeah. So next one is zinc amalgam, HCl, and red phosphorus in the presence of HI. And you know that zinc amalgam is a Clemmensen reduction. So Clemmensen reduction can reduce acids to the alcohols, but it can't reduce it to the alkanes. Okay. So red phosphorus in the presence of HI, yes, it will give you the compound. But again, the question comes here is like, it will help us to give you the propane compound, not as ethane. So I can say that red phosphorus is also acting as reducing agent, but this will give you a propane, but not an ethane. So B, in terms of B, this is wrong answer. So now you can see option 3 and 4 are a bit confused. So check option 3 and 4. Always remember, don't waste your time to check everything. So go to the options where there is a similar options are coming here. So you can see 3 and 4 are having same reagents, but it with the opposite thing. That is A has given in red phosphorus in the presence of HI. And what about the soda lime? So we can say the first one, CH3. Let me change the background. Yeah. So now CH3, CH3, CH2, COOH in the presence of HI, red phosphorus in the presence of HI. So what will going to happen in this case? This will helps in reduction. Okay. So you are going to have a CH3 alkane, that is propane, CH3, CH. Okay. So this will helps in reduction acids to alkanes, red phosphorus. On the other hand, if you are using soda lime, what is soda lime? I told you earlier, that is NaOH in the presence of calcium oxide, which helps in the decarboxylation. Okay, decarboxylation. So what is the meaning of decarboxylation? Just removing the CO2 from here. So always remember decarboxylation, the end product you will get with a less one carbon less product. So here oxygen, two oxygens and carbon will remove, that is CO2 will be removed, and whereas you are having CH3, CH3. Okay, this is an alkane which you are going to get. Got it? Yeah. So this is what the answer for the first question. Right. Next. So option C is the correct answer. Okay. Option C is the correct answer. So remember LiLH4 and this one, LiLH4 is the strongest reducing agent. It can reduce acids to alcohols or carbonyl compounds to alcohols. And another one, another reagent, NABH4. Okay, that can't reduce acids actually. It can reduce aldehydes and ketones to, they will convert in terms of alcohols. Got it? Yeah. So 52 question. This is another important question, guys. Which of the following might form cyclohexane on the reaction with dry ether? Okay, sodium in the presence of dry ether. Which of the following might form cyclohexane on the reaction with dry ether? So can you guys tell me what is the named reaction which is asked in the question number 2? Come on, what is the named reaction? Yes, probably you might guess that is a Woods reaction. Okay, so for the Woods reaction, there are so many reactions: Woods reaction, fatigue reaction, Woods fatigue reaction. So there is another reaction, fatigue reaction. Fatigue reaction is basically the compounds which we are using are cycloalkanes. Let's suppose if you are having uh, cyclohexane, let's suppose chlorine, you are having bromine, and you are using sodium in the presence of dry ether. Okay, so whenever you are using cyclo groups to form a cycloalkane compounds, so what will be the product here? You just remove the halides over here and just join both of them. Okay. Okay. So then this is fatigue reaction. And what is Urge reaction? Urge reaction is basically what? So I'll tell you here. So Urge reaction, if you are having an alkyl halide, CH2Cl, okay. And if you are using sodium in the presence of dry ether, and again, same story, you just remove the halides here and attach both of them, CH3, CH2, CH2 and CH3. Okay. And number two, if you see, okay, so fatigue reaction is also done. Another one is Urge fatigue reaction. What is Urge fatigue reaction? CH3, CH2Cl, one alkyl halide, and another one will be cycloal, any cycloalkane, cyclohexane, or any halides which are on the cyclo groups. Okay, and this is Urge fatigue reaction. Okay, the end product you can easily answer that. So this is about the Urge fatigue reaction, but the question was asking, not asking like that. They are asking in which of the following might from the cyclohexane. So if you can see, this is an alkyl halide. Definitely, it will not give you the product, desired product. Okay, because you are going to get, if you are using sodium in the presence of dry ether, you are going to get butane actually. You are going to get butane, pretty sure. And you are going to get dicycle hexane, you are going to get, means same, you remove the Br and attach another cyclohexane group here. Okay. And if you see the option 4 as well, you are not going to get the cycloalkane here. Right. So the point over here is like you are going to get bicyclo compound, or we can say that two cyclic groups will be present in option 1 and option 2, option 3. So definitely the answer will be 3. But how? How the answer 3 is the correct? Let's check its mechanism here. Okay. So now the question has given here Br, CH2, 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 and CH2, CH2. Right? So we are having 6 uh, carbons with the 2 Brs are attached at the both terminals. Now I am using sodium in the presence of dry ether. Again, it's a Woods reaction. What is the job it will going to happen? They will go and react as 2NaBr. So now the end product will be Br, you will have a radical here, and Br, you are having a radical. Now you can see these both radicals will join together. When they both join together, how they are going to form here? 1, 2, 3, 4, 5, 6. So the radicals which are forming here will going to join and form a 6-membered ring. So that 6-membered ring will be what? Cyclohexane. Cyclohexane. Okay. So cyclohexane is simply, we can say that this is a 6-membered ring. Okay. So this is how you can answer the questions, guys. So always remember, this is another important and easy. You can directly eliminate by eliminating the options also, you can answer this. Okay, just seeing that if they have directly given the cyclic compound, then definitely it will not give you a cyclohexane product. Next, question number 53. Question number 53 is another think type of question. Okay, so think question number 53. Okay, so question number 53. What we have to do in this question? Can anybody guess? Which of the following is the correct set of quantum numbers? So they are asking the set of quantum numbers. So what are the quantum numbers you know? Principal quantum number, yes. Azimuthal quantum number, which is represented as small m, capital L. And next magnetic quantum number, that is ML or simply M. And next one is spin quantum number. So next one is spin quantum number, that is MS. So the principal quantum number will be given by KLMN with the capital letters, or n is equal to 1, 2, 3, so on to infinite. Okay, and L will be starts from 0, 1, 2, 3, and n up to n minus 1. Okay, so the L value will be always considered n minus 1. And ml will be minus L2 plus L. These already you guys know, so that's why I'm not going so deep about it. Okay, so the ml value, L value will result from minus L2 plus L. And what are the total values of magnetic quantum number? What are the total values of magnetic quantum number? That is 1 minus L and another 1 plus L. So 2 L's and 0 will be there in between. So that's why 2L plus 1 will be the values of magnetic quantum number will be present. But the question and another last one is ms. Ms will be plus of and minus of. Plus of and minus of are the orientation, or we can say orientation of the electron, or the direction spin of an electron. Okay, spin direction will be tell one will be clockwise and another one will be anti-clockwise. So plus of if you take clockwise and minus of if you take anti-clockwise. Okay, so that is these are not the fixed values. Okay, some many a time students will get confused that plus of will be for taken as clockwise direction, minus of is for anti-clockwise direction. That is no need to confine with this. These are orbitally assigned values. These are not fixed values. Okay, so they are asking about what they are asking about. Now they are asking about which of the following the correct set of quantum numbers for the last filled electron of scanning. So now the question comes here is last filled electron. How do you know the last filled electron? How do you know this one? Last filled electron for the scandium. So for the scandium, last filled electron will be, first of all, if you write the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2, 3d1. So now till here there is no problem. You guys already know the order of filling the electrons according to the Hofbauer principle. So what is Hofbauer principle is telling that filling the electron from the lowest energy to the highest energy. Okay, so now how the energy can be found, which is having lower and which is higher, by calculating the n plus L value. Okay, so if you know the n plus L value, lower the n plus L value, lower will be the energy. So lower the n plus n value, lower will be the energy. Okay, so we can say that we have filling the electrons by increasing order of energy, that is n plus L value. So you already know L value for S will become 0, for P will become 1, for D will become 2, and for F will become 3. So you will have only SPDF for our syllabus. So L values will be 0, 1, 2, 3. Okay, but the question is like they are asking the last electron quantum number. So if you can see here, where is the last electron is entering? It is entering in the 3D. Okay, so we can clearly say that here the n value will become 3, and it is mentioned D sub cell. So that's why L value will become what? 2. Okay, and ML will can be what? Minus 2 to plus 2. That is minus 2 to plus 2 means what? What it will become? Minus 2, minus 1, 0, plus 1, and plus 2. Anything is there in the options, you can pick it up. And then MS can be plus or minus half. Okay, MS can be plus or minus half. Okay, so looking like that, we can clearly say from here, that is the answer will become 3 comma 2 comma 0 comma plus or minus half. If it is there, then our answer is correct. So yes, so option 1 is the correct. Okay, option 1 is correct answer, right? So that means 3 comma 2 comma 0 and plus or minus half is also another correct answer. Okay, now okay, yeah, so now 54. Which of the following is the not permissible arrangement of the quantum numbers? Again, this question asked from the atomic structure quantum number. These are the more frequent kind of questions we'll observe in our examinations. Okay, so going forward, that you have to make sure that these kind of questions are you have to answer them properly. Okay, so now think of it and answer the question. Okay, which of the following is not permissible arrangement of the quantum numbers for the electrons in an atom? So just write down the orbitals so that you will get an idea. 5f, 3d, again 3d, 4, yes, these all are possible. So the question thing is like there is no doubt with n and l values, everything was cool, but the I think it depends upon the m value. Okay, so for every possible m value, what is our discussion tells, for every possible l value, the ml values will be resides from minus l to plus l. That means if it is l is equal to 2, this will become minus 2 0 plus minus 2 0 plus 2, and minus 1 is also there, plus 1 is also there, but they have given for l value is 2, then this is minus 3. So definitely option 2 is not possible. They are asking not permissible arrangement of quantum numbers, so after 2 is not possible, so that is our answer. Cool. Yes. So then question number 55, the compound. Okay, the compound mx4 is tetrahedral. Okay, so the number of angles in this compound will become. So very another easy question, I can say that. Okay, so just think of it, tetrahedral, mx4 is in tetrahedral, the number of xmx angles are. So let's take one example, which is very easy. We usually take CH4. CH4 is tetrahedral. So how it is tetrahedral? It will follow sp3 hybridization. And you know how to find the hybridization by using the formula half into valence electrons of the central atom plus number of single bonds minus positive charge plus negative charge on the molecule is present. True. So now in case of CH4, if I'm talking about, so carbon will be at the center and three hydrogens will be at the bottom. So you may see like this, like if you see the arrangement, so the bond angle between the carbon, so hydrogen and the carbon will be 109 degrees 28 minutes. Because as it is a tetrahedral, the bond angle become 109 degrees 28 minutes. And one more thing, like remember, like if you are having one lone pair and three bond pairs, this will give you a pyramidal shape. Okay. And if you are having two lone pair plus two bond pair, then this will become what? Angular shape. Okay. So remember, two lone pair and two bond pair, it will become angular shape. But here you have four bond pair and zero lone pair, then this will become our tetrahedral, no doubt in it. But the question was not this. What the question is, they are asking how many x, m, x bond angles are possible. True. So you can check here 1, 2, 3. Okay. And you can also have 1, 2, 3, and you can also have 4, 5. Okay. So I will in short, I can tell you. In short, I can tell you 5 till now we have found. So to avoid the confusion, I'm writing m x1. Okay. I will take here x2, x3, and x4. And you can say that x1m, you are having two bond angles. Let me tell you. So m and x1, these are twice are possible, and mx1, these are three. Okay, that means 1, 2, 3. Okay, these are the three mx1 with three different, and 1, this is one angle, and 2 and 3. Okay, 4, 5, and 6. Okay, so total 6 bond angles are possible. If you see the linkage, x1m twice and mx1 thrice, this is another one, and next one you are having x1m 4, okay, and x2m 3, and x3 x2m 4, okay, and x2m 4. Total we are having 6 bond angles are possible in this case. Okay, so for the every set we can talk about. So every set you are having 6 bond angles for if you are confining between x, m and x, f, x, m and x, that is hydrogen, carbon and hydrogen, hydrogen, carbon and hydrogen. So total 6 bond angles are possible. Okay, so that is total number of bond angles are possible is will be 6. Okay, next. Yeah, the number of SS bond is H2SN06 is H2SN06. H2SN06. So they are asking about the number of, yes, SN bonds. Okay, so they are asking about the number of SS bonds. So we should know number of SS bonds. So always remember, these all are the sulfuric acids. If you see these oxides of the sulfur, okay, how do you find that one? Always remember, you should attach with double bond OH. This is the one set. Okay, so and another one in between sulfur will be present. Okay, and we don't know how many sulfurs are present here. Let's consider it as n sulfurs are there. S double bond O, double bond O, OH. Okay, so they are asking SS, how many SS bonds are there? N is there and 2 sulfurs extra is present. So that means you have to remove 2 sulfurs. That means N minus 2. So here we can clearly say from this one is, here you are having how many SS linkages? You are having SS linkages are N minus 2. If you are not getting the answer, just take one example of this one. S double bond O, S double bond O, S, OH, S double bond O, S double bond O, OH. So this will be H2S2O6. Okay. So H2S2O6, in this case, you can say that if your N value N minus 2, you are getting, right? So N minus 2 means what? Here, how many SS linkages are there? 0 SS linkages are there. So that means N minus 2, 2 minus 2, 0 SS linkages. Yes, we don't have any linkages here. So let's suppose if I'm taking in this case H2SO4, best example if I'm taking about H2SO4. H2SO4 will not give. So let me take another example here. H2S2O8. If I'm talking about H2S2O8, S double bond O, OH, double bond O, OO, S double bond O, double bond O, OH. Okay. In this case also they are asking about SS bonds. So we are having two S groups. So that is why N minus 2 if you take, again here getting 0. So there is no SS linkages here. So we can clearly say that N minus 2 will be the most correct appropriate answer. Okay. So N minus 2 is the answer. Okay. Next. Yeah. Question number 57. Take 1 minute of time and answer this. 57. Okay. Pause the video and answer it. Got it? Yes. So I hope you tried to answer this one. What is the question? The effect of temperature on equilibrium constant is expressed as T2 is greater than T1. T2 is greater than T1. True. Now log of K2 by K1 is equal to minus delta H by 2.303 R into 1 by T1 minus 1 by T2. Clear? So now in this case, T2 is greater than T1. So that means what? This whole entity will always become positive. No matter you can see it, okay, the whole will become positive. So as they are mentioned, it is endothermic. The delta H will become what? Positive. So the delta H will become positive. So this will become positive. Okay. And if this is positive, positive into positive and minus negative. So the overall quantity will become negative. So yes, this is positive. That is correct. Delta H is positive, correct. So here the question is saying that log K2 is greater than log K1 and log K2 is greater than simply K2 is greater than K1. So your answer will resides in these two cases. So if you are taking about this one, if this is positive, so that means what? The overall quantity will become, okay. So T2 minus T1. Oh my God, I've written wrong here. So if I am right, given question was like this. So if I am writing like this will become plus. So the whole quantity will become positive. So now this will means what? Log K2 by K1 is positive. So that is log K2 uh, minus log K1 is equal to positive. That means what? Log K2, okay, is equal to log K1 plus 1 something. So that means what? Always log K2 will be greater than this one. And then we can say that it is always greater than 0. Oh my God. So I think I have did a mistake. T1, sorry, this is becoming positive, right? Because as T2 is greater than 0. So sorry for the wrong option. Don't worry about anything. Just see the thing here. In the first option itself, we can eliminate the things. First option itself, because 1 by T2 minus 1 by T1 they are asking, right? Let's suppose if you take T1 as 300 and if you take T2 as 200, as they have mentioned, T1 is greater than. So that means what? 1 by 200 minus 1 by 300. It is obviously will become 300 minus 200 divided by 6,000, or 6 into 10 to the power of 4. Okay. So this means 100 divided by 6 into 10 to the power of 4. So I can clearly say from this one is, this is overall entity is positive. So if this is positive means, what about this one? 1 by T1 minus 1 by T2. Yes, definitely this will become negative. Okay. So, but the question in the option 1 given it is positive. Okay. So that means it will be negative is the answer. So by doing the calculations, we understood that option 1 is false. That one will become, if it is an endothermic reaction, the whole term should be negative. But if this is positive, what will going to happen? This will become negative and the overall equation will change. So that is why option 1 is the incorrect answer. So 58, if you can see, for the following reactions through the stages 1, 2, and 3, A to B and B to C and C to D. The following reactions through the stages 1, 2, and 3, A to B, B to C, and C to D is 1, 2, 3. Quantity of the product formed varies with the temperature given. Select the correct statement. Okay, they are asking you to select the statement. So they have given the graph between product formation and quantity of the product formation versus the temperature graph. So the stages 1 and 2 are endothermic, but 2 is exothermic. So now how the product formation and this one will depending upon whether it is an endothermic or exothermic. Okay. So that you should always think that the stages where there is a steep, we can also clearly understand from this particular graph product formation and energy gap. So this is simply nothing but activation energy. This is an activation energy graphs. Okay, EM1 and EA2. Okay, so if you remember, how do you find whether it is an exothermic or endothermic? By looking into the graphs. Okay, where there is an increase in energy is taking place. Increasing energy is taking place. That will be endothermic. You can see in the process 3 from A to B, there is an increasing in product formation. That means there is increase in temperature, which eventually indicates that is an endothermic. 1 and 3 are indicating the endothermic reaction. So you can see 1 and 3 are exothermic. Absolutely false. Option A, we can say 1 and 3 are endothermic. Yes. 2 is exothermic. Yes, there is a decrease in the product formation and there is a decrease in the temperature as well. So option 1 is the most suitable. 1 and 3 are endothermic and 2 is exothermic. Right. So question number 59, try to answer the question number 59. Take 2 minutes of time and answer this one. The first, second, and third ionization enthalpies of E1, E2, E3 for an element is 7 electron volts, 12.5 electron volts, and 42.5 electron volts. So this is 7 electron volt, 7 electron volt. Okay, and next one is what? 12.5 electron volt. And next one is 42.5 electron volt. Okay, respectively. The most stable oxidation state is cool. So I can say that whenever these kind of questions are asking, your options will be research from sodium, magnesium, and aluminum, sometimes potassium and calcium also. And on the other hand, you may also like they will talk about if you are where the removing of electron taking place, more energy is required. So you can see in the particular option, okay, if metal M is going to become M plus 1 electron, here how much energy is requiring? 7 electron volts. So then M plus is going to release another one more electron. How much this one? And third, if I am saying that M plus 2 gives rise to M3 plus 1 electron, you require how much electron, how much energy? 42.5 electrons. So we can clearly say this one is the stable oxidation state. When it will become stable oxidation state, tell me, when it will be see the stable oxidation state. So the stable oxidation state, in this case, we can see there is an energy gap. If you can see the energy gap is only 5 electron volts. But if we can see the energy gap between 12 and 42, it is almost, like 12 four times. Okay, so there is huge rise in energy here. So we can say that +2 will be the most stable oxidation state. Becoming a +3 is highly unstable because it will attain a stable electronic configuration. If you can see magnesium, which you can take Mg plus, okay, plus 1 electron, it's having some time index. Mg, say Mg plus 2, you required some more energy to that is 12 point electron volts. Okay, Mg plus 1 to plus 2 it will be coming. Okay, so from Mg plus 2 you are making Mg plus 3. That is why. So you can see that it required more energy, that is 42.5 electron volts, from jumping from Mg plus 2 to Mg plus 3. So jumping from Mg plus 2 to Mg plus 3, you required higher energy. So that is the reason we can say that option 4 will be the more suitable answer. Okay, plus 2 will be the more suitable answer. Right. So yeah. Next one, 60th question. You can see this is one of the most important question. 60th question. Match the oxide given in the column 1 with its property. Okay, Na2O, Al2O3, Na2O, and Cl2O7. So they have given some oxides here, and they are asking whether which is neutral, which is basic, which is acidic, and amphoteric. Okay. So to do this question, you should know the periodic trends. What will happen from left to right? What will happen from top to bottom? So usually, most metals are from the 1A and 2A are basic in nature. Moving from left to right, the basic nature decreases, acidic nature increases. Down the group, basic nature increases, acidic nature decreases. So on that hand, and we know that Al2O3 is a amphoteric, it can act as both acid and base. Na2O, remember CO, Na2O, and NO. These are the three neutral oxides usually asking in your examination. They don't behave as an acid or base. They are neutral in nature. Carbon monoxide, N2O, and NO. These are the neutral oxides, very, very important for your examination. So N2O is neutral. And I told you that and Na2O, that is metallic oxides, are basic in nature, and Cl2O7 are acidic in nature because these are halogens. All the non-metallic oxides are acidic in nature. Why? From left to right, acidic nature increases. So based on that, what is the answer? BDAC. BDAC. Where is this? BDAC. Yeah, option 4 is the correct answer. Okay. So I hope you understand this one. And next one. Question number 61. Small quantity of an industrial toxic waste is removed by. Very, very important question. This is from, I can say, uh, environmental chemistry kind of question. Burning in a closed bins, or the another option will become what? Small quantity of an industrial toxic waste is removed by burning in a open bins or controlled insertion. And next, it will be burning in the closed bins, and both 1 and 2 are correct. So guys, these kind of questions are usually asked in your examination. Okay, so if you are trying to answer these kind of questions, you should know the important thing is like environmentally it should be eco-friendly. Okay, but if you are burning controlled in insertion is we can say that which will not going to be a good idea. And burning in the open bins, usually that is the best method which are going to followed by industrial toxic waste. But the question is like small quantities. So if you are having a large quantities, it will be impact the atmosphere. So controlled insertion will takes much economic, I can say that money to do that. And next one, burning in a closed bins is also not proper idea because it may release some toxic gases as well due to the compression of these wastes. So I can say that if you are burning in the open bins, small quantities will not create that much havoc. So that's why burning in open bins will be the most appropriate answer for this question. Okay. So again, we need to check this one, but I think this is the most appropriate answer I felt. Right. Okay. Next question. Which of the following compounds can exhibit tautomerism? So we have discussed this in the revision section actually. So which of them will exhibit the tautomerism? Okay. So which of the following can exhibit tautomerism? So to exhibit the tautomerism, we know that ketoenol tautomerism. Okay. We know that ketoenol tautomerism. So in that case, ketoenol tautomerism, every first one is an aldehyde. Second one you can see there should be a alpha hydrogen will be present. In this case, there is no alpha hydrogen. In this case, no alpha hydrogen. In this case, yes, one alpha hydrogen is present here because this is carbonyl carbon and this is carbon alpha hydrogen. And here also no alpha carbon and no alpha hydrogen. So 1, 2, 3 will not, 1, 2, 4 will not give because to exhibit the tautomerism, we should have a alpha hydrogen. What this alpha hydrogen will do? This alpha hydrogen will undergo into the motion, we can say 1, 3, that is C6H5, C bond OH, double bond CH, bond C double bond OH. So this is how the keto and enol tautomer. Okay, I hope you understand. Right. Question number 63. Question number 63. Take your time and answer this one. Question number 63. Among the following, the most suitable isomer will be stable isomer. I'm so sorry. Most stable isomer is. So how do you find whether any compound is stable? How do you find it? How do you find whether any particular compound is stable or not? There are some concepts like hyperconjugation, and these all are cyclocompounds, or we can say that these are the conformers. Okay, these are the conformers of the cyclohexane. So we know that conformers chair form is more stable, and board form you will have a repulsion. Okay, so chair form is the more stable compound for the conformers of cyclohexane, but everything is given in the form of chair only, so everything will be stable. But the interesting fact here is like you have to watch the substituents and the alcohol group. So you may observe here, if you found any intramolecular hydrogen bonding, that compound will be more stable. So try to see intramolecular hydrogen bonding is possible or not in the cases. Okay. So if you can see in the option 4, option 1 and option 2, there is a possibility of having a intramolecular hydrogen bonding. So yes, in this case, the bonding will be there, but that is due to distance dependent. It is not that strong. But same in case of both are opposite, and that is distance dependent. And you can see the option 3 as well. Same option which was repeated, option 2 and option 3 are both are same. So I can say that both are wrong. But if you see the option D, okay, both are same above, and they are very near to each other. So there will be an intramolecular hydrogen bonding between them, which tells that these are stable compounds. So option 4 is the most appropriate answer. Okay, so that is same phase functional group, that is alcohol with any substituents like a methoxy or alkoxy group will form an intramolecular hydrogen bonding, and it will give you the stability. Okay, and question number 64. Strength in the volume of a solution contain 30.36 gram liter. So this is very important question. In the chapter you are having H2O2 peroxide, and you will have a volume strength relation, normality strength relation, and you have to study the H2O2 structure. Okay, these are the most important things in hydrogen chapter. So the question asking strength in the volume of a solution contained 30.36 gram liters of H2O2. Okay, so 30.36 gram liter of H2O2. So how to do this question? Strength of, we have to find the strength. How do you find the strength? So we know that the finding the strength, you required the formulas over here. Okay, so strength means grams of a solute present in 1 liter of a solution, right? So strength can be found by the, okay, 30.36 gram liter to how much volume it required, right? How much volume we can do. This question will keep us hold. We will need to check. There is one formula for that. 5.6 something it was there. Okay, and another one is like volume strength is equal to 11.2 into molarity. Volume strength is equal to 11.2 into molarity. This is another equation which is really important. And in this case, volume strength, we want to know that a volume strength is given. If you find the polarity, that is 11.2 into 13.6, 11.2 into 30.36, if you can calculate. So you are going to get the value approximately 10 volume. Okay. We'll check this one, the answer. And next one, question number 65. Question number 65. The ionization constant of ammonium hydroxide is 1.77 into 10 to the power of minus 5 at 298 Kelvin. Hydrolysis of the constant of ammonium chloride will be. So the ionization constant means we can clearly say that K. Okay. So this is coming from the ionic equilibrium chapter. So they are asking the hydrolysis constant. What is hydrolysis constant? KH. So how do you find the KH? KH is equal to KW by KB. Okay. And what is KB here? KB, as it is an ammonium hydroxide, so the ionization constant can be represented KB, that is 1/77 into 10 minus 5. And he said that KW. What is KW? KW is ionic product of water. So that will be 10 to the power of minus 14. And how do you find the KH? KH is equal to 10 to the power of minus 14 divided by 1.77 to 10 to the power of minus 5. Upon doing the calculation, you are going to get 5.56 into 10 to the power of minus 10. So option 1 will be the most suitable answer for this question. Okay. So the ionization constant is given, and if it is a base, we can say that KH is equal to KW by KV. If it is an acid given, so then it will become what? KW by KH is equal to KW by K, sorry, KW by Ka if it is an acid. Okay, right. Try to answer the question number 66. Question number 66 is another important question. Question number 66. How many total number of substituents are present in the following compound? Substituents. So first of all, to understand the meaning of substituents, we should know this, know the IUPAC rule. So main parent chain. How do you find the main parent chain? So you will find a chain where you are having more number of branches and longest chain length. So on that occasion, if you can see 1, 2, 3, 4, 5, 6, and 7 here, 1, 2, 3, 4, 5, 6, 7 is correct, and 1, 2. Let me go 1, 2, 3, 4, 5, 6, 7. Is there any other possible way? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 7. Okay, so always we should think of this substituents. They are asking how many substituents are possible in this case. So if we consider this as the main chain, so main chain, bromine and chlorine are under the main chain and alkyl groups are acting as substituents. So if you're numbering this one, two, three, total 4 substituents are coming. And another important thing is you are having an internal substitution. So if this is a substituent, there is another internal substituent, that is 1, 2, 3 if you take. So that means at the second position you are having a substituent. So that means overall we can clearly say that 5 substituents are possible. So this is the correct answer. 5 substituents are possible. You can easily guess by drawing the structure as well as two. Okay. So answer this one. Question number 67. Question number 67. Graphite is a soft, solid lubricant, extremely difficult to melt. The reason for this anomalous behavior in this is that graphite is a soft, solid lubricant, extremely difficult to melt. The reason for this anomalous behavior in this graphite will be graphite. Yeah. What is the reason? It is an allotropic form of carbon. No, the reason will be not correct. Yes, it's an allotropic, but the asking this exceptional behavior is because of what? Okay, it's a non-crystalline substance. No, it's a crystalline network structure. Okay, has carbon atoms arranged in large plated rings of strongly bonded carbon atoms and weaker plate bonds. Okay, another one sounds good. Okay, it has a molecule of variable molecular system. No. So option 1 you can directly eliminate. Yes, it's an allotropic, but it's not the reason. It's a non-crystalline substance. No, it is crystalline substance. As molecules have variable molecular masses like polymers. No. So option 3, if you can see, they are arranged in the large plated rings. Hexagonal rings will be present, and they are bonded with a weak bond between them. They are weakly bonded. So that is the reason we can say 3 is the correct answer. Number 68. Standard reduction potentials of the half cells are given below. You have to suggest the strongest and oxidizing and reducing agent. So always remember, strongest oxidizing and reducing agent decides upon the E cell values. So if you can see, these all are the E cell values, and these all are the E cell values. Always remember, if E is more positive, this is strong oxidizing agent. E is negative, that is strong reducing agent. So in this case, we have to see the strongest oxidizing agent, which is having more positive value. So for fluorine is having more positive value, that is plus 2.85 volts. Okay, and next we can see reducing agent, which should have less value. Iodine, that is I minus, is having the lesser value. So I can say that option 1 is the correct answer. Fluorine and iodine is the correct Answer which is having more value will become oxidizing agent, lesser value reducing agent. Okay, they are asking that and we have done. Question number 69. The initial setting of cement is mainly due to what? Hydration and the gel formation. Yes, because of the hydration and gel formation. Another straightforward question from the inorganic chemistry. Okay, think it. So cement के ऊपर बहुत बार questions आया है. So try to check it once. So again, you'll understand the importance of it. Okay, next. Okay. Na XH2 are approximately 50% H2O by mass. Hence, X is very good question actually. So how do you find the X to do this question? First of all, 50%. So you should know the molecular mass of the compound given below. So what is the compound? Na2SO4 dot XH2O is given. So we don't know the molecular mass. So that's why molecular mass plus of the X means water. We don't know plus 23 plus X. 23 into 2, 23 into 2, 23 into 2, okay, plus 32, that is for sulfur, and 4 times of 16 oxygen plus XH2O, okay. So, and after finding all these things, which is equal to molecular weight. So after finding all these things, the molecular weight is given as 142. Molecular weight is given as how much? 142. So that means 142, okay, plus 142 plus 18x divided by 100 into 50 is equal to 18x. So if you solve them, x value will become 8. So as simple as that. I hope you guys can understand this one. Okay, nice. Question number 71. How many grams of NaOH should be added to the water to PU 250 ml of 2 molar solution? So it is a dilute solution. We should always use a formula for M1V1 equal to M2V2 kind of formula. So as we don't know that one, so you can easily calculate it by using the formulas. Okay. Yeah. So you can do it by applying the molecular formula. And 72 molarity formula you can use, and you can follow the 71 and 72. NH3 gas is liquefied more easily than N2. Hence, okay, take your time to answer this one. We'll go with the easy questions inside the paper rather than doing everything. Okay. So see question number 73, real gas most probably. Yeah. So condition may mentioned, which is always correct. Low temperature and high pressure is the correct answer regarding this 73 answer. So low temperature and high pressure, low pressure and high temperature, low pressure and high temperature. Among the 4 options, where is the lower pressure and high temperature? Yes, so option 3 is the correct answer. Which is always correct at equilibrium? At equilibrium, which is always correct? Delta G is equal to 0 or delta G naught is equal to 0? Tell me which is the correct answer. Yes, delta G will become 0. Delta G naught is a Gibbs free knot at the standard conditions, but they are asking about only equilibrium. Correct equilibrium relation is delta G is equal to 0. Okay. 75. The phenol is treated with bromine water and shaken well. The white precipitate formed during reaction. So what is the answer for this one? 75. Tell me guys, what is the answer? 2, 4, 6 diprophenol. So this is the only one option. You can see the 76. So this is the correct answer for the third one, actually 75th one as well. 2, 4, 6 tribromophenol will help in the precipitate formation. And 76 is what? So here alcohol is there and Br came forward and this one. So phenol rigged the reaction with that. And this is basically how the bromine coming. Bromine is coming in the form of electrophile. So this is an electrophilic, okay, substitution reaction, not addition actually. It is an electrophilic substitution reaction. So you can also, it is substituting. So we can clearly say from that this is an electrophilic. What about question number 77? Question number 77 is a mixture of halogen question, okay, and hydrolysis. Very important question actually. So try to answer this one properly. 77. What about 76? P2O5 in the presence of an heating agent. Okay, think about that. What about 79? In the given following diazonium salt, which is most stable? Okay, stability of the diazonium salt. Next one. Amino acids are proteins with only activated benzene ring gives only. Proteins and amino acids. Okay, xanthophoretic test will be used for proteins. Amino acids like palings and bendix is useful. And the answer for the 80 will become proteins. Amino acids and proteins are proteins, not and amino acids are proteins with only activated benzene ring. So obviously, proteins can be tested by using xanthophobic test. Bendix and Felix solutions can be used for the carbonyl compounds as well. Nucleic acids are polymers and nucleotides, polymers of nucleosides, polymers are pure bases through the polyphosphate linkages. And we can say the polymers of the nucleotides, direct NCERT question, will become the nucleic acid. 75% of the first order reaction was found to be completed 32 minutes. What will be the 50% of the reaction of the time? So you can use by using the Bode's formula, you can calculate that, or else from the half-life period also, you know that T half is equal to 2 times the T 50%. Okay, so T 75% from the NCERT, already know that is equal to T 2 into T times of 50%. This is you already know in the NCERT. There is another one T 99%. So these kind of questions which are directly asked in the statement by show like that, they may also ask the questions like that. Okay. So 83, the rate constant for a first order reaction whose half-life was 480 seconds. So if the half-life is given, how do you find the rate constant? Yes, again, there is a put in, think about the first, that one, what you can say that first order period, chemical kinetics, that is half is equal to 0.693 by, okay, K. So that means 0.693 K T half. If let's suppose consider, just divide with it. If you are getting the answer 1.44 into 10 to the power minus, they themselves given first order reaction. Next, which is not true for a detergent molecule. It has a non-polar organic part and polar organic part. That is true. And another one is it is not easily biodegradable. Okay, it is a sodium salt of fatty acid, correct? It is a surface given acid. Okay, it is not easily biodegradable. Question number 2, you can see soaps and detergents are made from the long molecule that contain head and tail. Chemical formula will be C18H29NaO3. Okay, so in this case, we can say that it is a sodium salt of fatty acid. Is not true. Okay, the reason because it is not a fatty acid. It is basically a detergent and molecule and C compound. And question number 85. Among the following, the colored compound will be. Yes, again, colored question is asking. So think about this and answer. Okay. Right. So the answer for this question is Cu plus CuF2. The reason because Cu plus 2, which is having incomplete d orbital, and the rest of the other thing is having complete d orbital. So incomplete d orbital and Cu plus 2 will give the red color. Okay. I hope you guys understand this one. And next section 2 can be decided in the tomorrow class. Okay. I hope you guys understand the class. Thank you so much for joining. Bye bye.